Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by Freeswitch Solutions. Get support and professional services directly from the creators of the Freeswitch open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the Freeswitch advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-CLUE.
And welcome to ClueCon Weekly. Today is the 3rd of April, 2019. Today we're going to be joined by Tom Parrott from all the way from the UK. He's going to be talking about SRTP, TLS, and all the fun that he's had implementing this stuff with UK carriers recently. So stand by for that. First, let's jump over and let's see Miss Abby for the news.
Hi everyone, and thank you for joining us today on ClueCon Weekly. So, in celebration of our 15th ClueCon anniversary, for a limited time we are offering special registration pricing at $7.99. So I definitely suggest going over to ClueCon.com and registering, because that is the lowest price that we have had in over a decade.
Low.
Yeah. A special shout out to our sponsors over at SignalWire. They are offering $50 in free credit when you sign up for a space using the code CCWeekly19 in all caps. So all you have to do is go to signalwire.com, sign up for a space, use the code CCWeekly19, and your $50 will automatically be applied. Next week, right here on ClueCon Weekly, we have two very special guests. And those guests are Brian West and Anthony Minasali. And they will be here over at noon 1 week from today to talk about all things Freeswitch.
Perfect.
So they're going to talk about the history of Freeswitch, where Freeswitch is going, the open source project, some of the projects we offer, and answering your questions. So if you want your question answered live, meet us here next week at noon to ask those questions.
Answers from the experts.
Oh yeah. My favorite piece of news is that the call for speakers for ClueCon 15 is now open, but it's only open for about 2 more weeks, and we really want to hear what you have to say. So if you're interested in submitting a speaking proposal, go over to ClueCon.com. There's a lot of buttons you can click. Click on one of them and it'll take you to the page, and that's due on April 15th. The form is actually really easy to fill out. You don't even have to register for ClueCon yet.
Nope.
All you have to do is let us know what you're thinking about speaking, and we're going to look it over, and that's all you got to do.
And one of my favorite things about the speaking proposals is that if you're chosen to speak at ClueCon, your admission price is completely waived. So you don't have to pay for anything. You don't have to pay for the nightly events. You don't have to pay. It's all included, is what I'm trying to say. It's all included. The only thing that you have to worry about is your accommodation. So where you're going to be sleeping at night, if you sleep at all.
So if you know for sure that you're going to be at ClueCon, that's another great reason to speak. You don't have to pay for registration. Also, another great reason to speak at ClueCon is it's just a really great way to show off the open source project that you're a part of, or maybe you started, or the company that you work for, or even your own company. It's a great way to show off what you're working on, the projects that you're doing, and just get you or your company's name out there and show everybody why you're proud to have started that business, or why you're proud to work there, and show off to everybody all the cool stuff that you're doing, and get people to learn your name and you learn theirs. It's a great way to network as well.
Absolutely.
Yeah. So now we are going to introduce a new Blogspot segment that I just made up, and it is called Nailed It or Failed It. So on our Freeswitch blog, we talk about some things that might be considered controversial. And what I mean by that is not everybody agrees, which is great because it starts a dialogue and we get to hear everybody's opinions. So we definitely love talking about things that maybe not everybody agrees upon. So our inaugural Nailed It or Failed It topic today is, drumroll, wearable technology. Oh, very nice. So, if you have been to our Freeswitch blog before, you know that I've written about smartwatches a couple of times, and I am not a big fan of them. But I know a lot of you guys are. So I thought it would be fun, if we had a little discussion about why we like them and why we don't. So I am going to start with the reason I just learned about like a week ago. And that is, for Fitbit specifically, the 10,000 steps goal in order to help you lose weight is lies. None of that is true. It's made up by, not even by Fitbit. So there's no doctors who have said that. There's no scientific evidence that 10,000 steps a day helps you lose weight.
So where'd it come from?
Here's the kicker. So if you look up, like, will the 10,000 steps a day help me lose weight? Where did it come from? The first 4 articles are written by Fitbit. And one of the articles says that it was invented by a Japanese company as a marketing scheme to sell pedometers, which is what Fitbit is.
Yep.
So they didn't even come up with that themselves. They took a marketing scheme and just kept using it. None of it's true. The 10,000 steps a day, there's no proof that's going to help you lose weight.
Okay.
I think that's a fail.
So it's not scientifically backed, but as we all know, the more active you are, the better your health is going to be. Maybe even the more weight you will lose. The more active you are, the healthier you're going to be, the healthier you're going to feel. So it's not necessarily a bad thing. It's a little bit misleading.
True.
But it's a good way to keep those steps coming.
That's true. I guess walking can't be bad for you.
That's right.
So we'll let that one slide. Another reason that I've talked about already that I don't really love smartwatches is that there's nothing that a smartwatch can do that a phone can't. So like some of the things they advertise that a smartwatch can do is telling time, which even a normal watch can do that. The sun can do that. Receive notifications, send text messages, play games, video chat, track your health, call an Uber, order food, keep track of your calendar, notifications. Like all of those things is in your pocket. Like nowadays, nobody leaves the house without their phone. And I don't see the need to have 2 devices that can do the same thing.
Yeah, I can see where you're coming from on that.
Yeah.
But what I do have to say on that is not every phone is waterproof, but some smartwatches are. For instance, the Fitbit Versa or Ace, one of those, is water resistant up to 50 meters. So not all phones are waterproof.
That's true.
Some smartwatches are waterproof, right?
Yeah, maybe you really are expecting a very important email, but you really need to take a shower.
Yeah.
Then you can get notified even if you're in the shower.
Perfect.
Genius. Okay. Another thing that I don't love about smartwatches is that a lot of the cheaper, more affordable smartwatches, you cannot send a text or a call if you're not next to your actual cell phone. So nowadays there are standalone watches that do have a SIM card in them, so you can send a text or make a call even if you're not near your phone, but the charge does not last nearly as long and they're considerably more expensive. At least for now. Maybe in a year it'll change, but as of now, it's just if you want something with more functionality, you're going to end up spending more money, which makes sense, but
who's got all the money to spend on a smartwatch that can do what a phone can do, right?
Which it brings me to my next point is just, if you look at the market, people aren't buying, they're just not buying them. A lot of people who probably are watching this, a lot of people we hang out with are big tech enthusiasts. So they love just collecting all the new tech and seeing what it can do and playing with it.
Yeah.
But a lot of people who maybe aren't as immersed in that kind of world only buy tech that they feel like they need. And so a lot of people are just like, don't understand why they would need it. Or even if they think it's cool, it's not at a price point that they can afford.
Yeah.
Apple, to be fair, is killing the game. Apple Watch is completely fine. They have a lot of brand loyalty behind them. A lot of people like how Apple products connect to each other.
Yeah.
But a lot of other companies actually have started pulling production on smartwatches because no one's buying them. And Samsung actually completely shifted their entire marketing technique. So they were marketing it as something that you need. Like, this is going to make your life better. And it was not working. So they shifted and now they're pitching it as fashion.
Yeah.
So instead of it's something you needing, it's something that shows other people how cool and fashionable you are. So we'll see how that works.
Yeah. So those are all really great reasons. I love that this is what I love. And this is why I think they're a total success. They're trendy. So like you said about fashion and technology kind of merging, you could get a watch, you could get a smartwatch that's Michael Kors brand. Obviously we know about Apple brand, Samsung, Fitbit, there's all kinds of brands, and because there's all kinds of brands, there's all kind of price points. So we really widen the range of people who can purchase a smartwatch, which is great. Another reason that I think they're really awesome is because they can tell you about yourself. So they can tell you how many steps you've taken in a day. They can tell you about your sleeping patterns. They can tell you what your heart rate is. It's really helpful, and it's much easier than using a cell phone that's clunky and you have to hold it. Nobody likes to hold their phone while they're running. Right?
And a lot of women's clothes don't have pockets. Like even the athletic clothes, like they don't have pockets. There's nowhere to put your actual phone. So I can't see having like a piece of technology that you don't need to think about having. Like it's just there and you don't even notice it's there.
Yeah,
especially
absolutely.
for athletes. I definitely can see that.
And another really great marketing technique that Fitbit specifically is utilizing is that they are creating Fitbit watches for kids like the Fitbit Ace 2.
That's cute.
Yeah, so if you're on vacation with your family and you don't want to worry about keeping track of your kids so heavily,
like
right?
their cell phone usage,
like their cell phone usage, whatever it may be, they have an awesome Fitbit watch for kids that is swim proof, so they could be in the pool, at the beach, you don't have to worry. It's swim proof up to 50 meters, and it sets goals. So there's activity points that your kids can earn. It'll give the child virtual badges, virtual trophies. So there's a lot of really great ways that this Fitbit is promoting an active, healthy lifestyle, especially for kids, which I think is really awesome.
Especially nowadays, because like, of course, no judgment, but a lot of these kids are growing up with technology that even we didn't have when we were kids. So a lot of them are inside playing PlayStation all day or sitting on the iPad. So they're not as active, I don't think. Of course, kids are still active, but I do think they need those reminders to like get out and play.
Yeah, and I think that's really awesome, the way that it gives you a reminder to get up and move around. And also another really cool feature of this specific Fitbit Ace 2 is that it allows parents to set safety controls. So they have approved phone calls from like friends and family that they can do. So you're keeping your kids safe even while giving them the technology.
Because like a lot of parents don't want to give their child a cell phone. Because A, they're expensive. B, it can be dangerous.
Yeah, absolutely. Absolutely.
That's a really cool twist on Fitbits.
Yeah, and I know we talked a lot about the price points earlier, but Fitbit actually just released their cheapest smartwatch ever, which is the Fitbit Versa Lite, and it's probably at least $200 cheaper than the current Apple Watch right now.
Well, that is nice, because a lot of people, while I'm sure they could afford this technology, like they don't see a reason for it. Like they can't justify the price for what they're getting. Yeah. So I think that opening up the market and kind of being available to like a wider range, like a wider audience could definitely shift the tide for smartwatches. They might start picking up sales. Yeah. Yeah. So that's our discussion for today, but we want to know what you have to say. So at us on Twitter or on Facebook, or just comment in the YouTube comments what you think about wearables, if you think they failed it or nailed it. One of those. And let us know what controversial topic you would like to see us talk about next. So that's all we have for today. Back to you, Ken.
All right, thank you very much, ladies. So let them know what you think about that type of device. Anyway, let's jump over and talk to Mr. Mike Mavroudis and Mike Jarris on Community Corner.
Hello.
So just to start out, I got one of these. And I think the best feature to it is the fact that I get to see how much I sleep. And so I know the week of ClueCon, I average about 3.5 hours of sleep.
Well, you get a lot of
Okay.
sleep for ClueCon, I guess.
So today we have a question from Slack, from a member of the community. And that question is, I have a Digium TE13 card with no hardware echo cancellation. I configured my trunk for RFC 283, but my phones connected to the T1 interface are bleeding DTMF. On some of the services, I get double DTMF problem. How do I solve it?
I mean, this is a hard one to answer in a good way. The gateway's job is either to pass through the in-band DTMF or to detect and fully squelch the DTMF. If the device you bought doesn't allow for that because it doesn't have the capability, I wouldn't use it. Most gateways do. We've got some things built into Freeswitch that kind of let you do this on the free TDM side. We're really not supporting that anymore. There are ways to squelch extra DTMF, but what it comes down to is you either need something that fully removes the DTMFs from the audio stream and replaces them with signaling, or just don't do it at all and use the audio. You got to pick one, and if your tool isn't good enough to fully remove them, you should just use audio instead.
Get a new tool.
I mean, honestly, in this day, buy a gateway. Buy a gateway that has hardware that can do this. They aren't that expensive, or use a SIP service. But you really, to do that right, you really need to do it at the point that you're actually detecting the DTMF. We added, like I said, something into Freeswitch that'll let you kind of squelch those out, buffer it a little bit. You trade off a little bit of delay to do it. I think that's just in free TDM, but if your device isn't doing it, the answer is that's not the right device for you. The workarounds would be to turn off the DTMF detection all the way on the card side and not negotiate 2833 at all. Just pass through the audio and call it a day. It will make your life.
So I did end up calling the person after, and he resolved it. And so what he did was he just killed all the in-band and just used RFC.
Okay.
Simple solution, right?
Yeah, if you're running a detector on top of negotiating 2833, that's always going to give you troubles.
Okay. Thank you, Mike. Answers from the experts.
Yeah.
And the other thing is, use all VoIP. Forget the PSTN.
The PSTN dead, guys. Even the carrier don't really do it except for the outside. It's time to move along.
Yep. Okay, so today we have Tom Parrott. So, Tom, what's new with you?
Thanks, Michael. So I'm here. I was invited on here by Anthony to talk about my project I've been working on last few weeks for deploying encrypted calls between our carriers in the UK and Freeswitch 1.8. I thought I'd talk a little bit about the service that we provide at Infinity. I'm the CTO, and we've been going since 2010. And we've been using Freeswitch since pretty much day one then, right the way back to, I think, like 1.2 or even before that, potentially. And we use several different carriers to provide a call tracking and conversation analytics service. And what that basically means at a top level is that we're trying to tie the calls that are driven from your website, we're trying to tie those back to the online marketing source that originally drove those calls. So it's a marketing technology tool. And from a technology level, what that we effectively provide are lots and lots of tracking phone numbers, which you put on your website or you put on your offline media. And then we receive those calls in through various carriers. process them, record them, route them, etc., and then forward them back out to a PSTN destination number back out through one or more carriers. And
you can move a lot of numbers that way.
Yeah, absolutely, especially with the dynamic tracking that we do, because we provide for any particular company that provides our service, we provide them with a pool of phone numbers that actually dynamically changes for every visitor that visits the website. So you're effectively providing a bunch of numbers just for one particular client. And security has obviously been a big concern for us, and so although we like to have the flexibility of interfacing with carriers over the internet, actually doing encryption and making sure that the call media and the call signaling that's transferred over the internet is secure, we've been exploring recently using encryption. And one of the precursors to that was actually to find carriers that actually support it, because it's not out of the box supported by many carriers. So that's been one of the main challenges, but we've succeeded now in doing that. So I thought I'd just go over and cover. Can you see my presentation? I don't know if that's visible yet or not. There you go.
Okay, what's up?
Thanks, Ken. So what I thought I'd do is just go over a little bit of how SIP and RTP streams are constructed. This is a presentation I gave internally to some of our tech team, and probably for the audience here, this is very, very well known and very obvious, but I thought I'd cover it anyway, just to get a good baseline. Then I'm going to go through how we enabled TLS signaling on Freeswitch, cover some of the challenges with that regarding SIP tracing and a tool we use internally called SNGREP. I'm then going to go through how to enable TLS on our outbound gateways, so when you're routing a call out to a destination carrier. And finally, a little bit on some experience I had with configuring different SRTP ciphers, so the actual encryption of the audio. So to just give a quick overview of the basics of SIP and RTP. So here's a simple setup where you've got a handset connected to a Freeswitch PBX box, and that in turn is using a carrier upstream to make outbound calls and connect outbound calls onto the PSTN network. So especially when I'm explaining this to non-technical people or people who are not familiar with SIP, there's an expectation or an understanding that when you say SIP call, that the actual call audio itself is going across the SIP protocol. But of course, that's not how it actually works. And the SIP signaling is just the information around setting the call up. So who's calling, what number you're dialing, etc. And that tends to go over either TCP or more traditionally UDP on port 5060. And that's a well-known port for SIP. The actual audio is set up via SIP, but the actual audio itself is flowing using normally a random port, and it uses a different protocol called RTP, or real-time protocol. And that is always, as far as I know anyway, always done over UDP, irrespective as to whether SIP went over TCP or UDP. So in this example, everything here is unencrypted. So the media and the signaling between both the handset and the carrier is totally unencrypted. So what we want to do is, so these red circles here identify the problem. This is what we're trying to encrypt, basically. And we've got to encrypt all 4 of those communication channels to actually have a fully secure call. So encrypting RTP. The way RTP is encrypted is still transmitted over the UDP protocol, but it uses a slightly different protocol called secure RTP, or SRTP. It uses the same random port range as RTP, and the keys for each session for each call are exchanged over SIP. Now, although you can encrypt the media of the call without encrypting the SIP setup of the call, it's really not properly secure, because you're effectively transmitting the encryption keys required to encrypt the audio in plain text across the internet via the SIP channel. So what that really means is that we need to also encrypt the SIP channel to fully secure the SRTP media stream. Is that all making sense so far? So the next step is to... Sorry,
you ever try using RTP?
It's a good point. ZRTP is great for, I think, if you're doing pure SIP end to end. But in our situation, where we're actually receiving calls from the PSTN network and then forwarding them back out, what we've found is that isn't really supported generally by the carriers. And also, we tend to sit in the middle and actually do the call recording as well. So we record the media stream. So we do actually need to decrypt it halfway through to produce that call recording.
Yeah, that makes sense.
It's hard enough finding a carrier that will actually support TLS and SRTP, but ZRTP would be ideal for end-to-end encryption.
Well, you know what a lot of the carriers do. They'll basically accept the encryption at the border, and then as soon as it hits the border, it's just regular. It's just yeah.
So I mean, I've actually going to be in contact with some of our carriers to understand exactly what they do and their interconnects with different upstream carriers. Several of the ones we use actually directly connect with the national PSTN networks using SS7 and private interconnects. But yeah, I am sort of aware that in certain cases they could just be decrypting it straight away and sending it across the network through a different carrier. This whole project has been really to try and improve the security between us and our immediate carrier, and it's kind of been the policy that we don't want to let the perfect be the enemy of the good, and trying to improve things where we can, but with an acceptance that actually doing end-to-end encryption over PSTN is just not something that's totally viable.
I think a lot of it has to do with just the legacy equipment. So the tandem equipment just doesn't. A lot of it doesn't support it.
Yeah. So the next step to getting secure audio between us and the carrier was to actually encrypt the SIP. Now, when you use encrypted SIP, it actually goes over a different port, and that's port 5061. And if you've been using UDP as your SIP transport, encrypted SIP actually requires you to switch to TLS transport, which is the same underlying protocol that we use on the web for visiting secure websites, so HTTPS, and it's effectively requiring you to use the TCP transport with an encrypted layer on top. It uses and requires using certificates and keys like you would normally with HTTPS, and that brings with it some of their own challenges, which I'll go into a little bit later on. So here's the diagram from the beginning, and if we enable TLS both between the handset and the carrier from a signaling perspective, and we enable SRTP between the handset and the carrier, then we've effectively encrypted both legs of that call when it's going over the internet, which is our target. So how do we do that? How do we enable TLS on Freeswitch? It's pretty easy, actually. In etc. Freeswitch vars.xml, there are some global variables that we need to define. I think these are probably defined by default in the vanilla config, but in case they're not or they're missing, these variables here will effectively provide some global variables which you can then use to activate TLS in the actual SIP profile itself. I've chosen here to enforce TLS version 1, 1.1 and 1.2, and to not allow the older SSL version 3, which isn't secure anymore. And then there's some cipher presets in terms of disallowing low security ciphers. the next step is to modify your profile that you want to enable TLS on. And there's a set of TLS related parameters, which I've sort of written down here. And you can see also the last two, I've used those two global variables that I defined in vars.xml in the profile to pass that configuration on. One thing to note is that the TLS certificate directory, TLS cert, if that is empty, then when you start Freeswitch for the first time, it will generate a self-signed certificate and drop that into that directory, which is great for testing. And I'll come on to a bit about certificates later on. You'll also notice that TLS verify in subjects I've left empty, and I'll touch on this a bit later. But the key point here is that we are not verifying upstream outbound carriers at this time. So to now activate TLS on a carrier outbound, so on a carrier gateway outbound that actually supports TLS, it's pretty simple. Effectively, where you would normally specify the host name of the gateway, you add :5061 to force the traffic out over the TLS port. And then where you would normally, if you may or may not be using registered transport, but if you are using registered transport and you've specified UDP or TCP, you need to change that to TLS, which tells Freeswitch to establish TLS connection when opening the connection. And then if we just left it at that point, then when we originate a call out through that gateway, the signaling would go over TLS, but the actual call media itself would not be encrypted. It wouldn't be using SRTP. And so you can do this a number of different ways. You could modify your dial plan to set the channel variable RTP secure media to mandatory. But what we've done is, rather than actually having to modify our application to understand that some carrier gateways are supporting encryption and some aren't, we've actually defined that channel variable on the outbound gateway configuration itself, so that if you select and route a call out through a gateway that supports it, it will automatically be encrypted on that outbound leg. An example of an originate call command is there as well. So self-signed certificates. Freeswitch will generate a self-signed certificate it's missing. It's stored in a file called etc freeswitch tls.pem. The problem with using self-signed certificates, and this applies to HTTPS and web browsers and WebRTC and all the same problems, is that it doesn't allow the remote side that's connecting to your server to verify that you are who you say you are. The encryption is still as strong, but you cannot be sure that you're actually connecting to the service or the server that you think you're connecting to. And there could be a man in the middle attack going on where somebody is actually hijacking your connection and doing something malicious.
So how do we protect against that?
Well, you need to use a certificate that is from a certificate authority. So someone like Let's Encrypt or any of the big ones. The prerequisite of doing that is that your carrier that's actually routing the calls inbound to your server needs to actually be verifying the certificate that's being offered by your server. So if they're not verifying it, then there's no real benefit, because your DNS could be hijacked and your calls, SRV records could be routed to a different server, and it's up to the inbound carrier to actually be verifying your certificate. And if they're not doing that, then using a proper certificate doesn't help, which kind of brings me on to the next slide, which is that in my experience, not all carriers actually verify the inbound certificate on the server anyway. I've experienced issues with using Yearlink handsets where if the certificate that you've been issued by your official certificate provider is using SHA-256 as the cipher or as the signing cipher, then the Yearlink phones can't understand that, and so you have to disable all verification on the certificates anyway on the handset in order to connect. So I haven't got experience with other handsets, but that has been a bit of an issue. The other problem is that Mod Sophia at this time, as far as I know, doesn't allow you to live reload certificates, and that makes things like Let's Encrypt, which is very popular at the moment, but it only issues certificates that are 3 months old. They can only be used for 3 months, and then it automatically applies for another certificate. And normally, if with the case of like Apache Web Server or Nginx, it would issue a reload certificate command to apply the new certificate. With Mod Sophia, we can't do that at this time, and so you'd actually have to reload the whole of Mod Sophia or restart Freeswitch, and that of course is going to knock out any active calls or registrations on that box at the time. So it you then have to be looking at using something like a long-lived certificate, like a 1 year or a 2 year certificate, and even then you then have to you have to be scheduling in maintenance at the right time so that you never let the certificate expire. Otherwise your inbound calls will fail.
You know what though? Certificates are so cheap these days. Like you get a 3-year certificate for like $10 almost.
Oh yeah, it's not a cost thing. It's more a maintenance thing. You want to be restarting. I'm sure you want to be doing maintenance on your box more than once a year, twice a year. But I'm thinking, unless you need to be, as soon as you introduce certificates that are not auto renewing without admin, you really need to be looking into doing things like monitoring the certificate expiry in case that date passes and all of your inbound calls fail because your upstream is verifying your certificate and the date has expired. But yeah, Let's Encrypt is really useful, and it would be great if Mod Sophia could support live reloading of certificates without draining calls down, because it just means you would never have to touch it again. It would just automatically carry on renewing certificates. So, assuming that you've now got TLS encrypted and the signaling is all encrypted, both legs, this introduces a bit of a problem. We quite often have to run SIP traces and send those off to carriers if we're having any problems with audio negotiation, codec negotiation, calls not connecting properly, DTMF not being recognized properly. We have to send those SIP traces off to our carriers to help them diagnose the issue. Because the SIP traffic is now encrypted, we have a problem. We cannot capture the raw SIP packets off of the network and in a PCAP file and send them up to the carrier, because they'll be encrypted. They'll be unintelligible. A tool we've used for many years, and it's really a fantastic tool, I really recommend it, is SNGREP. It's a lightweight CLI tool, a curses tool, which allows you to effectively run a packet capture, but it will actually recognize SIP in the packet capture in real time and break the packets down into each individual call that's going on, and you can then browse using your arrow keys and drill into each call and see what's going on. And it also then allows you to export a PCAP file of a particular call, which you can then upload to your carrier for diagnostics. Unfortunately,
SNGREP is a great tool. Yeah,
it really is. It's fantastic. The problem is that as soon as you switch to using encrypted TLS signaling, SNGREP ceases to work. It relies on raw packet capture to understand and recognize SIP packets, and because they're encrypted, it just stops working. There is, according to the manual, a experimental mode that if you supply it with the private key that you started your Freeswitch server with, it claims to be able to decrypt the raw packets, but only if you specify Freeswitch use a certain TLS cipher. I'm guessing it's a cipher that doesn't have perfect forward secrecy enabled. To be honest, I've tried a little bit with this, and I was never able to get it to work. So, and especially as it's experimental, it's probably not something to be relied upon. Hopefully it will improve in time, but at this point, it's not something that I could get working. So we needed a solution.
You can do it. You can do it with Wireshark too.
Yes, yeah, indeed. I think the challenge with both SNGREP and Wireshark is really you want to get to a point where you're leaving the trace running all the time, and it's then breaking the trace out into different calls. So you can say you can zero into a particular call and have the entire transaction, even if it's over two different TCP connections. So an inbound and an outbound leg, you actually join the whole session together and just export that particular trace as a PCAP file that you can then upload to the carrier. Otherwise, you end up with all different calls sort of merged into one PCAP file, and that can be quite hard for the carrier to figure out what the actual issue is. So the solution we came up with, and it's one of the reasons that we upgraded to Freeswitch 1.8, was that Freeswitch added support. I think it was in 1.6, added support for using the HEP protocol, which is from the Homer project. And effectively what that does is it will decrypt the SIP packets that are coming in and out of Freeswitch, and then forward them on to a capture server that's running. Well, we run it locally on the same Freeswitch box in a sort of lightweight encapsulation protocol just over UDP. So going back to the original diagram, it looks a little bit like this. We run SNGREP, and SNGREP supports acting as a capture server for Freeswitch. So we configure Freeswitch to send packets to the local loopback address on the HEP port. And then when we run SNGREP, SNGREP will actually listen for those packets that are unencrypted and print them out and allow us to use SNGREP as normal. So to enable HEP on Freeswitch, in the global, in the sophia.conf XML file, there's a global settings section, and there's a capture server section where we specify where we want to send the decoded SIP packets to. And in this case, we're just forwarding them to the local loopback address on port 9060. If you were running the Homer SIP capture service permanently, you might forward that off to a different IP address or host name in your network that's running your capture server. But in this case, we're just using SNGREP's built-in Homer server, HEP server. Now, one of the in order to enable SNGREP to capture HEP, you modify the etc SNGREP RC file and add the following lines there, which basically tell it to listen on the local loopback address on the specific port and turn listening on. One of the sort of edge cases, one of the problems I found with using this approach is that first line there where it says set capture device LO for the local loopback. So one of the bugs I found is that because we've currently rolling out encrypted SIP, and we've still got some carriers that don't support encrypted SIP, when you run SNGREP, what you end up with is you still got the raw packet capture mode enabled in SNGREP, but it's also getting the decrypted SIP packets from Freeswitch even if the original inbound packet itself over SIP was not encrypted. And that means that SNGREP will actually capture the same packet twice for the same call, once directly off the network for the carriers that we haven't enabled encryption for, and once relayed from Freeswitch over HEP when SNGREP is set to listen on the HEP protocol. So there's already a bug open for this with SNGREP that's been confirmed, and hopefully they're going to give the ability to disable raw packet capture in the future. However, for the moment, if you're not expecting any SIP traffic actually on the local loopback address, then you can just tell SNGREP to turn its raw packet capture only to the local loopback address, and so you'll then just sidestep that problem. The next issue that we found with SNGREP is that although you start to see the calls coming in correctly on SNGREP when using HEP, one of the main reasons we wanted to use SNGREP is that we wanted to export that as a PCAP file and send that up to our carriers. Unfortunately, when receiving packets over HEP, although they visually look okay, when you export them out through PCAP, they effectively become like text files, even though they've still got the .pcap extension, and so they are garbage effectively, and they can't be opened by Wireshark or any PCAP analysis tool. So I logged a bug for that, and the SNGREP guys have already sort of approved that, and they'll be looking at that. But in the meantime, the workaround is that SNGREP does support a plain text export format, which does work with the HEP listener. So it's not as good as a PCAP, but it's workable for diagnosing issues.
Did you ever play around with Homer?
I haven't yet. I definitely want to. It looks really good, but I haven't had a chance yet. At the moment, what we're doing is we've just got a small shell script called SIP capture that uses the FS CLI command to enable the global SIP capture mode temporarily, which then starts sending packets over HEP. It then runs SNGREP with the HEP listener enabled, which means packets start flowing into SNGREP correctly. And then when we exit SNGREP, once we're done, there's a bash script that as part of the bash script, it's got an exit handler, which then turns off the global SIP capture. Because one of the things I noticed was that if you leave global SIP capture turned on all the time with HEP enabled, and you haven't got the SNGREP or a local listener working, is that you'll keep getting these logs in syslog from Freeswitch saying, I think it's like a transport error. It's saying unable to send packet, which makes sense because there's nothing listening for it. So it just got quite noisy in the logs if you leave global SIP capture on all the time. So some more bugs. What I found, this bug was the original reason that Anthony invited me to come and talk about sort of my experience with rolling this out. What we originally started to notice when we were using SNGREP with HEP is that outbound packets from Freeswitch up to the carrier, or outbound packets sent from Freeswitch to the handset, were correctly decrypted and sent on to SNGREP via HEP. But all inbound packets, so invite packets or anything that's coming from the remote side into Freeswitch, was not relayed onto through the HEP protocol and onto SNGREP. And there's a bug link there. I'm pleased to say that that's now been merged into master, so hopefully that will be in the 1.8.6 release. But at the moment, we've just rolled out our own patched version, and that's working really well.
That's cool.
It was actually a really small fix. So, I mean, I'm not a C programmer, but I was able to dig through the source code in Freeswitch, figure out what was going on. And I think it was probably just a copy and paste error. In the Sophia library, there is a different file for each one of the SIP transports supported. So there's there's T-port UDP, T-port TCP, and T-port TLS. And I noticed that if you're using HEP with TCP SIP, it was working fine. But as soon as you enabled TLS, you started losing all the inbound packets. So having a look through the source code and identifying there was only like 2 or 3 lines that actually caused the SIP packet to be sent over HEP. Those 3 lines were missing from the T-port TLS file. Adding those in and recompiling Freeswitch then fixed the problem. So it was actually a really small patch. Okay, so the sort of the final thing that I experienced when rolling this out, and I'm not sure whether this is a Freeswitch issue or a carrier specific issue, but I did start to see these errors when we were using SRTP. We started seeing these RTCP unprotect error and invalid RTCP packet type 6 version 0 length blah 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 errors over and over again in our logs. And the way I sort of started to play around with the different SRTP ciphers, and I stumbled upon the fact that using this particular cipher, the AES CM128 HMAC SHA-180 cipher, seemed to fix the problem, and those errors disappeared. So I don't know if that was our carrier negotiating a particular cipher and then not encrypting the RTCP packets correctly, or whether Freeswitch wasn't able to decrypt RTCP packets when a certain cipher is used. But if you pin the cipher to that particular one, then those errors go away. And the final thing for me was that I noticed when doing that in the vanilla config files in vars.xml, there's a mention of this RTP SDES suites variable. And as far as I can tell, that doesn't do anything anymore. It's been taken out or is not used because it seemed to be doing the same thing as the RTP secure media suites variable does, but it didn't actually have any effect. So it took me, I was scratching my head for a while thinking, I'm changing the ciphers here, but nothing's actually happening. There's still the same ciphers are being offered. So that sort of threw me off the trail for a bit. And that's everything from me. Any questions?
So what challenges did you have when implementing this?
The challenges were around initially getting Freeswitch to actually send inbound packets over HEP and patching that. That sort of, it put me off for quite a while because I wasn't confident enough to jump into the source code, but eventually I sort of plucked up the courage and dived in. And it turned out to be, not a particularly tricky fix in the end. The other thing was all the stuff around TLS verification and trying to get things like the Yearlink handsets to work with real certificates. And we kind of parked that for now because we had to turn off verification anyway. So there was no real need to use real certificates because you don't get any of the benefit from it. And really finding carriers that actually support TLS and SRTP, they're not as widespread as you would think, at least in the UK. But we've partnered now with a carrier in the UK. We've got an international carrier that supports at least TLS signaling. And we've got a carrier in the US that supports it as well. So we're looking quite good now in terms of being able to roll that out fully across all of our numbers.
It's actually, it's really interesting. I never heard of anyone sending HEP to SNGREP. It's actually a pretty cool idea. I mean, SNGREP's a great tool.
Yeah, it's certainly good as a stopgap solution until you've got something more permanent like Homer set up, where you can just dip in and extract the particular call issue. But if you can recreate a problem repeatedly, then you can just jump on the server, start SNGREP, which will start the listener, and then you can make a test call, capture the PCAP or the text file, in fact, and send that off to the carrier.
Cool.
I suppose some of the other things that I've learnt, they're not necessarily problems, but I found it quite inconsistent, the SRV protocol naming, because with SRV records for TCP and UDP, it's _SIP _UDP or _TCP. And then when you come to enable TLS, you suddenly have to do
TLS.
Well,
Yeah.
no, not in my experience anyway. You'd think it would be, but it actually turns out to be _SIPS with an S _TCP.
Oh.
Because it's SIP secure, I guess. So that threw me for a bit as well.
And then the text string is different too, right?
Yeah, you have to set port 5061 or whatever your inbound port is as well.
Okay, cool. Well, thank you for coming in today.
Thanks very much. Thanks for having me.
Ken, back to you.
All right. Thanks very much, Tom and Mike. And also thanks to Mike and Mike Jarris and Abby and Madison and everybody else that makes this possible today. Don't forget, guys, next week we're going to have Brian West and Anthony Minasali here. So we'll be back here at noon Central Time on Wednesday to record that live. So if you want to join us, you know where to look on the social media for the links for that. You can pop into YouTube and watch live and even ask questions to those guys, and we'll get them in here for you. Don't forget, like I said, next week at noon U.S. Central. It's GMT -6 right now, I think. So we'll see you guys next week. Y'all have fun.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at freeswitch.com.